Zoom. Should have done that before I'll let you guys in. Yeah, thank you. So given 50% of the total material use in Europe is associated with buildings and other civil infrastructure and construction activities produce the highest amount of waste amongst all sectors, it's paramount we look to reuse and well, definitely promote reuse. And to quote Roy, who's on the call today, he's often saying you've got to use less, use it wisely, and use it again. So yeah, we are lucky to have Roy Fishwick, not from Clevedon still, as I've stupidly typed here, or my colleague, I asked my colleague to type, but from Cleveland still, and Tom Howarth from EMR. Tom's obviously spoken before, a few weeks back. Let me just let the guys in. So yeah, really good to have the guys here today to talk with us. So between Tom and Roy, they've got a presentation that they will share, and then any questions from the floor, please stay on mute, but use the chat facility to ask the questions. And as I said, this recording is being recorded, and we will promote it for future viewing purposes. So should we start? Let's start with Roy, because you're at the top of my screen. I'm presuming you're at the top of everyone's screen there. But yeah, just introduce yourselves, hand over to Tom, and then Tom can open, and then I'll stop sharing the screen, Tom, and you can share your presentation.
No problem. So I'm Roy Fishwick. I'm the Managing Director of Cleveland Steel. We've been repurposing rather than reusing, although we did use a lot of second-hand pipe back in the day. Tubular steel now for 50 years this year. I've been at the business for 35 years, so I know a lot of the detail very intimately. And it's that experience that's brought us to the position we're in now with the reused steel for construction, with sections specifically, because there's a lot of overlap with the legislation and the technical aspects. And I've been working, sort of lobbying on the reuse side against legislation since 2012 as well. So yeah, been playing at this for a while now. And Tom?
So I'm Howarth, senior engineer at EMR Reusable Steel. So I've got a structural engineering background. Part of that's a lot of sustainable design and looking at kind of circular economy on central London projects. And then from that, I've been going on to looking at, I was working on demolition site, so actually seeing steel reuse coming out of a building. And then since then, I've joined EMR and I've become part of the reusable steels team. So that's looking at reusable steels all the way from kind of recovery to the stockholding side, testing, and then into new designs and projects.
Cool. Cheers, guys. Just out of interest, then there's obviously Cleveland and EMR. How big is the marketplace in terms of people looking at reclaiming steel or to supply of reclaimed steel? Is there many players, or you're obviously the biggest?
In terms of the suppliers, if I'm honest, it comes down to ourselves and EMR at the moment, primarily. What complicates that scenario is there's an awful lot of projects that are looking in true circular fashion to themselves for the material. So there's probably as many or more, certainly in terms of tonnage, projects that are looking at the steel that they've got to then incorporate back into new structures. And of course, that's coming from planning and circular economy policy, mostly in London, but also in other areas now. So a lot of the times the material supply is the existing site already.
Okay, cool. And that's what we said, and that's what we were alluding to when we were talking off camera, or that people have been doing this for a long time in terms of reusing the steel in the same location, well, from the same site, but just in a different place on that site.
Yeah, so I think we've found that quite a bit, is that a lot of people trying that have actually run into a lot of problems with the specific project site retention on site. There's difficulties with that, especially when it comes to storage and processing it within the site constraints. So this is where I think us and Roy, us and Cleveland have been coming in and actually providing this service to do everything that you need to do with your reused material outside of the site and then process it. And it's also the fact that what you have as a reused material, reclaimed steel, might not actually fit what you're trying to put back on site. So if you can put it into the wider market, you can actually get these kind of circular economy benefits, carbon savings on the wider market on someone else's project, rather than trying to jam it into your own project.
And it's just to say as well, it's a bit of a mixed message. I mean, I sat through a presentation recently, but there's a general message that goes into the marketplace about reused product, which is that you should design around the reused materials that are available. And if that's windows, for instance, then that makes a lot of sense, because obviously you need to have openings in your structure that are the same size as the windows you're going to put in. I argue against that quite strongly on steelwork. What you need to do is design an efficient structure, not decide you've got a load of sections and then try and make a building out of it.
Yeah.
Because you only have to get to about 25-30% of over capacity on the steel before you've cancelled the benefit in carbon terms. So it's not a brilliant idea to look at a big pile of steel and see what you can make out of it, not least of which because you might not actually end up with the building you want, which I would have said was really stupid. But, so I think if you're looking at windows and doors, by all means design to accommodate them, but for the structure I think you've got to do the work properly and efficiently and then find the metal that suits.
Definitely. We've been talking a lot about efficiency recently, and there's a lot of discussion about trying to create efficient designs based on what's available. But actually, we have a thing of you should just design everything efficiently as if it's new, and then see what actually fits that design. And we can, even if you don't get 100% on your project, if you can then get it on 10% on 10 projects, you actually get that 10% really efficient.
And I think to back Tom up with that as well, the percentages are important because we see this. My personal view is that if you look across the marketplace, the end game for reuse is probably 20 or 30%, maximum 40% in the whole market. And that's sort of utopia, because the rate of demolition versus the rate of new consumption, we're not going to get anywhere near 100%. So why set 100% or 90% target at the start of a job and hamstring yourself and potentially use material inefficiently? Recognize at the moment it's not happening at all and get a 10 or 20% in quotes easy win.
Yeah. So that's where you start design for deconstruction then, as opposed to reconstruction. Is that, if I read that right? Is that
partially? It's more so we'd say design new efficiently. So as if you were designing it efficiently. So get those kind of high utilizations, low minimize your material use. And then once you know what you've got in your design, then you can look at what's available in the reuse market and what fits your design, and you know that what you're bringing in is an efficiency, rather than trying to look at a pile of steel and make your building fit that pile of steel. But when you do that, you're going to have columns that are way too heavy, beams that are way too strong for what you actually need it for, because that's what you've got. But if you're using something inefficiently, what you're actually doing is preventing someone else using it on another project efficiently. So it's that kind of consideration of who should get to reuse steel. I think that's where it comes with the stockholder model, is that we can actually provide that to different projects and look at where that material is going to be used most efficiently, rather than trying to put it from one project to another project. If it's just that singular kind of line, you then struggle with actually getting your material to fit the new project, because it could be a completely different grid or design. But is it worth me going into?
Absolutely. I don't want to steal your thunder by asking silly questions now, and you can be sharing your deck. So
so I think it would be good just to give everyone here that may or may not be familiar with kind of what's happening with steel reuse at the moment in the market. And on developments, there's been quite a lot of case studies, and it's gaining a lot of momentum actually recently over the last couple of years. And what I'll do is I'll just give a quick overview of kind of the circular steel life cycle that we're seeing. So what both us and so EMR and Cleveland Steel provided this kind of stockholding service, but this fits into the whole kind of circular life cycle of steel, where different kind of parties have different roles within this life cycle, and this whole life cycle can be applied to kind of other materials. So this is it for steel, but actually for a lot of reused materials, it's a kind of a similar process. Quite a good template. So we're starting with the existing structure. Then this could be, the client may look at reuse potentials, pre-demo audits for this by looking at kind of the surveys and steel recovery plans. So, starting with the existing structure, you might identify that there's some reused materials for reuse steel potential there. So you can do that through the survey, and then if you identify it as reusable, you can then kind of start getting together some kind of steel recovery plan of how do we actually get that material out of the existing structure and to the stockholder and that often involves these kind of slightly different methods to traditional demolition. So we're moving from a demolition to more of a deconstruction approach. So once we've kind of got a plan in place of how we're going to get it out of the building, we can then look at a careful deconstruction. So there's a lot more care in the actual deconstruction of the building to get it out in a good, usable condition. So preventing damage and making sure that you're getting as much material out for the next project to use. And now this is where we come in as stockholders, is that once it's being deconstructed, it gets sent to the stockholder. And we provide a service that manages the testing and certification. We store it for the amount of time, and we will do defabrication and then send it to the refabrication supply on the new project. So just giving you a little bit more detail on the testing and certification. This involves kind of all the stuff that we need to do to understand what is the performance, what are the grades of the material that we've been provided. So this will tell you the strength, grades, and chemical compositions and stuff like that the designers need to know to design with new steel. Then, in terms of defabrication, that's removal of existing features, and the kind of the amount of defabrication required can depend on the design that it's going into. But that's just making sure that it's ready to go into the new building for the refabrication. And throughout this process, we can be working with the designers to understand kind of what they need in terms of the performance of the material, and does the material fit their design. So there's a kind of a stock mapping process of saying, you need this is your shopping list, and we have this in stock, we can supply you with that much. And then when it gets to there, it gets to the supply and construction. So by the time it gets to here, by the time it's gone through the process of testing and defabrication and refabrication, once it comes to the site, it's almost like just getting new steel with a few extra considerations into a project. Because we do all the hard work at this point to get it into the new project, and by that time, it's you're almost building into your frame as if it's a new steel section, maybe with some additional features. And then that can loop back around to the existing structure. Touching on the big driver on this, I mean, the big driver with any structural material is the carbon impact, but also, the also wider biodiversity, land usage, water usage impacts of not having to take a raw material and take it through the process. For steel, the big impact is a big impact in carbon, and that really comes down to the fact that by taking it out of material in a full length, usable length, you don't have to actually take it to a recycling kind of furnace and chop it up and then melt it down. So there's a lot of energy involved in kind of, even with EAF and blast furnace with scrap input, there's still quite a lot of energy involved with melting that steel down and then reforming it as a new section. So if we can retain it as a big section, it gives a really significant carbon benefit. But this is a big driver being the carbon benefit. But then there are challenges with actually how do we access that source of reused material. So I've got some slides on specifically one of those challenges being warranty certification, but I don't know if you want to, Simon, if you want to touch on that slightly later on and then go into a bit more of a general overview, a few questions on the more general challenges with reused steel.
Well, if we can come to any questions at the end, and we can focus on let's move on, and then
okay.
Yeah. Thank you.
So one of the big challenges with this, I know there's quite a few different challenges at every stage of that kind of circular life cycle, but one of them comes into is how do we actually kind of warranty and certify it? And this is not just a challenge for reused steel, but for materials, how do we actually warranty and certify it to get it onto a new project and make sure everyone's comfortable having a reused material on the new project? And what's happened with steel is that we've had a guidance document that the Steel Construction Institute provided that gives a kind of pathway to this warranty and certification. And the good thing about this, so this has actually enabled a lot of steel reusing projects, and people are getting a lot more comfortable with steel reuse as more projects do it. And in terms of the warranty and insurance there's a lot more kind of understanding and comfort around it. But what is good, taking this as a kind of a case study as an example, is that you could almost look at any material you want to reuse and kind of have a bit of a template of how do you take a material that you have and get it to reuse and certification. So what will you do to, understand the properties, test it, and get that into design and make sure we've got confidence that what we're using is fit for what it's supposed to be used for. Obviously, with anything structural, there's kind of a higher consequence to a structural section failing compared to maybe an office desk or something like that. So there's different kind of considerations for depending on what the material is, but this kind of gives a good template. So the SCI published these two documents, P427 and P440, which covers a kind of it's kind of like a roadmap to how you take steel coming out of building and what you have to do to get it to get warranted. The supplementary document, so the first document covered anything erected after 1970, and then P440 came in as a supplement to take that back to 1932. And this document has kind of some high-level criteria of what are the initial tick boxes that you need to do to reuse steel. So stuff like not being subject to fatigue, not having fire exposure, plastic hinges, stuff like that. And then it also sets out the requirements for testing to understand the properties, and then how that actually fits into the kind of who takes responsibility for what when it comes to warranties, CE marking and stuff.
Sorry, Tom, what does happen to, say, steel from bridges and other uses that you can't reuse under the circumstances? Are they then melted back down if you were to source those?
Yes, they are recycled, and I think in this kind of context, that actually recycling for a lot of steel is actually the best solution, because there are a lot of kind of barriers to reuse and making sure that it's actually suitable for reuse. And the SCI kind of gives you a lot of these. If you have anything that doesn't meet these criteria, then recycling is actually your best option. And within that, there may be slightly different routes of where that recycling goes that you can kind of look at. But I don't think this is the idea of reuse is not necessarily saying reuse is good and recycling is bad. It's very much a case by case basis. Sure. Is reuse possible, and is it appropriate, and does it meet the reuse criteria? And if not, then actually recycling is going to be your next best option.
Yeah, well, that just goes back to the common sense approach that, like Roy mentioned earlier on, about sort of if the goal is to use 20% as your, it's not setting 90, 100% as the goal. It's using a much more realistic. Then within that, for understanding, so then recycling does have a place to play. Sorry, Tom.
There's a couple of factors as well that sort of have to keep reminding people of, if you like. But the first one is that steel is 95 or 98% recycled. So steel is currently recycled at an incredibly good rate. So we can't improve the recycling rate, which is why reuse is going to have a global impact, which is the point I was going to make before. The problem with 100% target is that you're making a really good project, but are you actually helping the global climate emergency? Are you actually helping global carbon? And a lot of times people are too focused on the one job to really see the overall impact. And with the environment we're working in now, you'll get called out for that. If you just go chase a number that's brilliant for one project, the market's too informed to go with that kind of greenwashing anymore. So you've got to look at the overall impact. But the other thing is, because scrap is recycled, we can't lose sight of the fact some reusable steel is scrap. We're not creating a problem by scrapping some of it. We're just allowing it along its way rather than trying to jam it into the supply chain when it doesn't fit. So it's not a disaster because we scrapped some reused steel. That's almost business as normal. What you need to then allow for also is economics. There's no two getting away from it. So we can recover anything at sometimes vast cost. And in fact, the market still isn't in a position where it's going to swallow that. So as a very simple example, we've got steelwork here that's covered in shear studs. If you want that cleaned and polished back to look like a brand new piece of metal, it's about £2,000 a tonne. Well, I've yet to meet the client that wants to pay £2,000 a tonne for something they can currently buy for less than £1,000. So we've got to always factor these things in. And I think the supply chain suffers with this because we all live in our own bubble within the different sectors. So an architect's view of the world is different from an engineer's view of the world, is different from a contractor, etc. And we've just got to try, when we make the decisions that drive this process, to take account of each of the stages, and to understand other people's problems within that. And the certification and warranty does fall into that.
And just to make one of my usual naive points, in terms of steel, just from what you're saying now, I mean, the reuse of scrap metal is a pretty perfect economy. I mean, it's a business that there is, like, my idea of scrap, as in, you know, we produce all this plastic and it ends up in landfills. Steel, metals, they don't end up in landfill, do they? There's a business around scrapping. So that it's not as if steel is a resource that is wasted. There's a market that has evolved to ensure that it does find a new home and it is reused in some form or other.
Yeah, absolutely. So this is, I mean, the fact that we've got such a high recycling rate of steel at the moment is actually a really good place to be in. And then now we're looking at the next step of, out of what we're recycling, what is reusable, and can we take that? And I think it's important to touch on. So obviously this covers the high level tick boxes that you have to reuse steel, but on a project by project basis, there's so many other factors in terms of site constraint, your program, what's the cost of getting it out, and there is a bit of a cost. There's a bit of a payback because you get it in a higher value material. It's higher value as a reusable than it is as scrap. But then there's a higher cost of getting it out. So there's an economic kind of argument of, you know, if we get all the easy sections that are really easy to access and get out, we might actually be, you know, the value of that actually might outweigh the cost of getting out. But if we're getting every single tiny section that's really difficult to access, and you can't get the train in the right place, then it becomes way more expensive. And is it actually worth, within your program, to focus on what are the big easy wins? And if we could do that on every single project, you know, rather than having one project that's 100% recovery perfect, could we get 100 projects where it's business as usual to get the stuff that's got the highest reuse potential, highest value, highest carbon impact, and accept that, you know, the stuff that's a lot of the stuff that's got the lowest impact is also the hardest to get, like the small sections, trimmers and stuff like that. So maybe it's not a debate between 100% reuse and 0% reuse. Sometimes it's a middle ground where you can fit it within the program and get a really good outcome.
Cool, thank you. And so just mind going back to your first slide, Tom, just about 1,000. Did I see that was 1,000? Sorry, not for the second slide. Then there's a 1,000. So only approximately 1,000 tons of structural steel was reused last year. And just to give me some context, how much is 1,000 tons? What example of building? I mean, how many buildings does that represent? Like, how many office blocks? How many new homes? What 1,000 tons?
I mean, that could be so. Just to clarify this, so 1 million tons of steel is recycled from UK demolition every year. So that's what's coming out of the kind of demolition sector, scrap recycling. And then only about 1,000 tons.
Yeah,
over 1 million. Yeah, and then only about 1,000 was actually reused. So that's actually stuff that's gone through the process and got onto new buildings. So we still have 90% more coming out.
Yeah,
but it's not yet being put onto a new building. But that one is a very small percentage, and I think the big potential there to scale this up massively. But with that, 1,000 tons might be one kind of 6-story central London office block with a, you know, it's not a gigantic building. It's not a skyscraper. It's
one or two moderate buildings essentially. The only thing with 1,000 tons is that the statistics are very poor for steel, because normally steel has only been measured as waste coming off site, and that's measured as scrap. So there isn't actually a good database that's been capturing what goes where after it leaves site in a skip. So there is actually, I wouldn't want people to see the 1,000 tons and be disheartened. I think there's actually a much higher value of steel that is reused, but not through stockholder supply chain necessarily. So it's used in refurbishment. It's used, I mean, scrapmen historically have always had a corner of the yard where they sell material for domestic refurbishment or for farm buildings. And so reuse is reuse. It doesn't have to be a London office building. It just has to be replacing new steel with reused steel. It can be bollards, for goodness sake. It doesn't actually matter what you've done with it as long as you've substituted new steel.
Yeah, definitely. I think there's a missing link here of actually understanding what's coming out of our buildings and what is, reusable. But I think that the scope of this, it isn't meant to be disheartening. This is meant to show that we've actually got a really big potential to get to scale this and get something in the industry as business as usual. Because what we're finding, and Roy, you'll probably agree on this, is that we kind of have got to a place now where we've had some pretty challenging case studies that have happened, and then we've learned a lot of lessons, and now we actually know that there's probably 100 projects in the UK that we could take those lessons and apply them and get some reused material out of them. But there's just not enough awareness and not enough kind of understanding, and people are still kind of getting a bit hung up on the risks and the challenges and the time impacts, that they kind of shut it down before actually realizing that it is possible. So this is something that we're trying to raise awareness and messaging around, is that there is a big potential there, and we've actually solved a lot of the issues that previously, maybe 2 or 3 years ago, would have been a big barrier to reuse.
Yeah, because I mean, obviously, when it comes to promoting the reuse, that's clearly one of that's like, how do you go about doing that? But anyway, we can come on to that if we have enough time. I'm conscious now, whilst I said I wouldn't interrupt you, that we've probably got another couple more slides at least, haven't we?
Yeah, so I think, so just we'll try and not go into too much detail on these, because this is one of the big challenges that we've kind of had with reused steel and now overcome, is steel kind of the certification, warranties and insurance side of things. And this is quite a good indication of how you can take a reused material and get it through that process. So you could use this as a template for any other material you're trying to warranty. But yeah, I'll let Roy cover these slides on steel certification.
Yeah, sure. I mean, the first thing to understand is that all new steel comes with a certificate, and that is the declaration of performance from the manufacturer. But regarding most of the sort of geometric type, so straightness, size, dimensions, weight per meter, that's all done through ISO 9000. So businesses like ours are ISO 9000, so we can do the same sort of statistical measuring, etc., to prove those basic properties. The wonderful thing about steel is that you can be, well, I say wonderful, it can be destructively tested without destroying all of it, and you can get the exact same properties from reused material as from new. So you're able to ascertain exactly what steel is to the same level of detail that you get for new material. What's important is that it has to be fit for purpose. Now, that's currently driven basically in steelwork through EN 1090, which is the CE marking. And there's a lot of issues. It's what got me involved 12 years ago, lobbying Europe and UK government, because new standards typically involve writing new standards that accommodate new products. And nobody was looking over their shoulder at the circular economy or reused materials. But the take-home message is that the CE marking does allow for alternative products to be used than new, but you have to declare their properties. And that means that the stockholders, such as ourselves, have to do the testing. We have to make the testing available. The real big breakthrough was P427, which is the reuse protocol, because that basically, in lieu of a standard for reuse, which is coming, it gave a protocol that people could follow that has been backed up by the engineering science. So you're able to now, we can declare we've followed that protocol, and the supply chain is reassured by that level of detail. As product suppliers, we're able to provide product insurance because we've followed that protocol. The insurers are happy that we've done the necessary work to put material to the market that's fit. It doesn't absolve engineers of designing something that's fit for purpose in its own right. We're just declaring the fact the material is fit for the purpose that it's being asked for, which is where the engineer specifying the execution class comes in. So as reused material suppliers, we're not telling anybody what the material is good for. We're declaring its properties so that engineers can then deem them fit for the purpose they're going to be used in. So it's not disrupting the normal insurance and warranty process for the normal supply chain. It's just changing a little bit of the input data, essentially. So we're providing material as a stockholder with certification that's been done by independent laboratories and some of the QA work that's been done by us, as opposed to normal stockholders, which just would be passing you a mill cert through. And it's important as well, just from a reassurance point of view, to understand that the amount of testing that's required of new products actually typically is less than you would see from a reuse situation. So you're going to have more specific data from reuse typically from the testing than you would get from mill production, which is done on a statistical basis essentially. People get hung up about the type of certification. I don't think this is the forum to discuss 3.1, 2.2, yada yada certs. The point is that it doesn't actually matter. That's been tested now. It's gone through the UK government, etc. That everybody's pretty much in broad agreement. But you will meet resistance in the marketplace to do with the type of test certificate. The thing that's very reassuring is that EN 1090, the CE marking standard for steelwork, is currently being redrafted and will come out in the next year or two with a reuse protocol within it. And that is based on P427. So the UK has led the charge, if you like, along with a couple of Scandinavian countries. So what we're saying here is what is going to become in due course an actual standard, which will give everybody reassurance throughout. But at the moment, the insurers, etc., are using the P427 as the guidance that everything's been done correctly.
So,
yeah,
if they accept it, then who's to resist it? Who is resisting the prime steel guys then, or just lazy?
No, I think it's just resistance to change. I mean, to be honest, one of the most practical problems is the fabricators. And it can't be ignored. I mean, we've got an issue at the moment ongoing because the fabricator is a main fabricator with millions of pounds worth of equipment, which scans the beams before they go in. So if it sees an existing drill hole or a weld scar, it actually rejects the beam as being not good as new. So you've got very strange practical resistance at grassroots almost. And you see it on demolition. I went to visit a site where we wanted to get the steelwork and I reported back to the head office, yeah, that's absolutely no problem at all, but you're not going to get it because having talked to the man on the ground, he's going to bring this thing down the same as he's done the last 50 before it, and it's going to be a mangled mess by the time it hits the ground.
I think there's a lot of it comes down to practical considerations, and there are actually really reasonable, understandable considerations when you look at it as a problem. It's like, we've set up our industry to work on new materials and and demolition to be for recycling, which we've been drilling it down. You've got to take it down in this way to recycle it. Yeah. And then when we're producing new steel, it's got to be within these certain tolerances. And reuse is a completely different mindset. So we're now completely changing how we do the deconstruction and recovery. And then when it comes to fabrication, especially, is that they've set up all their automated lines for stuff that's completely clean without any existing features. Now, these existing features, from the engineering and architectural standpoint, might not be an issue. They might be say, right, it's not making it any weaker, it's still got strength and it looks fine. We're happy to redesign it, but then when you take it to a fabricator and they've got an automated line that they've got to run it through, you've got a big plate in it and it's going to hit the automated line in it. It's really simple, really kind of simple practical considerations that sometimes get overlooked and can actually cause a big issue when it comes to getting these on projects. Sure. So these are the kind of things that between us the industry is trying to now solve and drive.
So that on that, I mean, just instead of being obvious, when it comes to deconstruction in that instance, clearly it's going to just cost a lot more to take buildings apart in a way where you protect the materials to use them again.
Yeah, to an extent, but it's getting more efficient. And the people, I mean, we're working with demolition contractors who are actually quite intuitive in terms of they understand that actually, yes, it does cost more, but then you're getting a higher value material, so you're getting more value for your materials. Yeah. So as I said, there is a balance to it. Is what can you get out in the time you've got, and what is the big wins in terms of the you're usually looking at your long primary beams and columns, but if you're looking at every single trimmer, then they're actually a lot more difficult. But there is that kind of you are actually retaining the value of the material, so there is a kind of that analysis. And then also from a cost perspective, yes, there are cases. I mean, generally, I'd say on the whole, it does cost more than new steel, but not significantly more. So you're looking between, either cost parity or 20%, 30% more maybe. But the carbon benefit you're getting from that is absolutely massive. And if you're comparing it to other low carbon materials, other kind of way, you could look at it from like the low carbon EAF steel, which costs more than standard steel. So you still have that kind of cost analysis that you can do. Yeah. And it's just another thing that you can compare it to. So
no, absolutely. And my previous question just highlights that, just focusing on the cost, the monetary cost, and not the carbon cost. So
the other thing I think, just to pick up though, is we've done a couple of jobs, I've been involved with a couple of jobs where the demolition has been cheaper. So it's horses for courses. So there's two things I would say is that in some instances, because when metal is scrapped, it has to be chopped into very small pieces. If you've got the infrastructure in place to bring it down in bigger pieces, Tom and I would be much happier buying them in the longest length possible, which saves time and energy on site, less lifts, less cutting. Yep. So that's one. So portal frame sheds would be a classic example. If the right equipment's on site, that can be done cheaper. The other thing which I keep trying to explain is go for the easy wins. And people keep looking at these 100% solutions. So if there's 1,000 tons in a building, it might be possible to recover 100 tons at no additional cost, 300 tons at a minor additional cost, for which you're going to get paid a premium. Yeah. Then actually look at the rest of it and go, do you know what? We're not even going to go anywhere near that. And I know I offended a big London firm of engineers about 18 months ago because they came to me with a building that was concrete encased columns, and they wanted to know how to take it off. I said, don't even bother. Just chuck it in the skip. Forget it now. And sorry,
that's part of the story that recycling isn't necessarily bad. There's stuff that's going to be better suited to recycling, and we should be putting our effort into what we know is going to be really good and reusable and give that highest benefit.
It's pick your fights, and I don't mean fights, but you know what I mean. It's pick your battles essentially, and that's what's absolutely fundamental. And it does go back to my point before. You've got to understand each aspect of the supply chain as well as to what the impact is on them.
Yeah.
Because there's certainly one of the problems at the moment is that the whole industry is very much top down. So the poor fabricator at the bottom or the guy doing the erection is the man that's really taking the pain. And it's, well, Tom will have seen it as well, I'm sure. We've seen projects come unstuck because it's been too broad brush or blue sky thinking at the very top of the process, if you like.
Mm-hmm.
If you don't have engagement across the chain, you're going to get caught. We've been caught by problems I probably should have seen coming that I just didn't know were going to come, because it is the nitty gritty, unfortunately.
Absolutely. And going back to this initial kind of slide that we've had here, if we're going to try and get as much of that 1 million tons from all the UK demolitions, we're not going to do that by telling everyone their demolition is going to cost twice as much and take twice as long. We have to look at what we can get within our kind of constraints and boundaries, because realistically, I mean, there are some clients who have been really driving case studies and putting a lot of resource and effort into making this happen and learning those lessons. But what part of those lessons is, you get diminishing returns, and what Roy just touched on in terms of what you get for no impact, some impact, and high cost. It's something that we're really trying to change the mindset on.
But it sounds to me like it's quite an efficient market as it is, because people understand the value for what they're doing. I mean, so yeah,
it's more important than that, actually, just to mention, especially if you're involved with an asset that's to come down, is that the scrap has traditionally always been a cash flow item for the demolition contractor. So they typically discount their demolition cost by the amount of money they're going to get back from product they can sell.
Yeah.
So there's a lot of asset owners look at their building and consider the steel is theirs. Well, it won't be if they didn't tell the demo guy up front, because he will have discounted maybe 100, 200,000 pounds from his cost for what he knows he's going to get paid for the metal if he scraps it.
Yeah.
So there's all sorts of funny little intricacies. Now, I must keep emphasizing these aren't really barriers. These are mostly things we've learned and sorted out.
Yeah.
So in telling people about them, it's not to try and frighten them or make it sound difficult. It's just to make sure people have got their heads around it.
I'm taking the barrier. This is a positive, because there's an existing market that understands the value and it operates in a certain way, and it's now working with those guys, for you guys to speak with the demolition guys. It's almost like you don't need to get them on side because they know.
Yeah, no, there's been a bit. It's taken a little while, but they're definitely, the demolition industry is now very much on board with this. You can see this across the piece.
Yeah. Cool.
It's getting more efficient. Yeah, it's getting more efficient as well. So that where that cost, time balance actually lies is going to get higher and higher. It's going to get better and better for what we're getting out of buildings. So
in terms of sort of examples, case studies, or people advocating the reuse of steel, are there? I mean, obviously, from a legislative perspective, are people incentivized to do this as well? I think in a previous call, Tom, we were talking about how with Arup that even though it's potentially more expensive, it still makes sense for people. People are incentivized to reuse steel in the materials.
We're not seeing kind of government leadership on this, but I think on a local council level, there is driving kind of circular economy initiatives, and from an industry, the industry is definitely driving it as a whole. There's a lot of kind of people have ESG commitments now, and they're actually looking at how they can achieve these. So this is getting really driven by the industry. I think on the council level, there's some good aspirational kind of initiatives there, but there needs to be a better understanding of the kind of the whole circular economy and what that looks like on specific projects. Before, if you start putting in targets, it can actually be almost, you've got to be careful and make sure you do it in a sensible way, because if you put in a target for 50% reuse on a project, that project can only ever get 20% realistically, then it's going to look bad. But if they get that 20%, they've actually done a really good job to get, what they could have done. But if you get 50% target for one that could have had 8% reuse, and they we just get 50 and hit the target, and they've actually not done that a good job. So it's that kind of nuance that is kind of difficult to capture. And that's where we have to have people within the industry who really understand it and really understand their projects, kind of drive with that mentality of what can we do for the circular economy, what can we do for reducing carbon, but also the wider, taking into account wider biodiversity impacts and stuff like that. And to kind of make these decisions.
So I think the strongest driver, ignoring sort of planning, if you look at things like the M&S building in London now, but it's been proven in a couple of studies that the buildings with low carbon footprints are actually got a higher rental value, for instance, when they're selling out. So you've got big corporations that are looking, basically, to be blunt, for the publicity of having done the right thing. So this whole process quite fascinated me in the way that it's been driven in my involvement over 10 years, because what we saw was it's the engineering businesses that engaged first, weirdly, because they needed to make green offers to the architects that were making them to the clients, because the client wanted to be able to demonstrate, for want of a better word, the greenness of their building. So the supply chain hasn't been pulling reused steel through at the bottom end straight to fabricators. This whole process has been driven right up at the top end, and that's purely because of the corporate aspiration for helping with the climate emergency, etc. But the benefit is people that are doing that are seeing financial benefits for their business, either through the rental values or just through credibility issues and what people are prepared to trade with them for.
Definitely. I mean, even not. I know the muddying of the recent waters with Sunak and trying to sort of water down the whole net zero program, but ultimately, many of the lenders, there is still this. They haven't changed. I mean, they still want their loan book to be full of properties that are, EPC rated B, A, etc. Just because the government may have relaxed their stance doesn't mean that business has, because and through that, people are then going to be wanting is exactly that the properties will be worth more that have invested.
And it's more than that as well, because with construction, the net zero targets in a lot of cases miss the point. That is, you can see in a lot of instances in construction where there's huge embodied carbon values going into projects for things. I mean, the example I give is our business here. We've put 0.5 megawatt of solar on the warehouse roof, but the solar panels themselves have got a 7-year payback for the embodied carbon. But actually, that energy consumption by comparison to everything else on our site is bugger all. That is our net zero. And in terms of our annual impact of consumption of carbon is nothing. whereas the embodied carbon that's involved in the entire site, buildings and everything else, is much, much higher number. So these are very important numbers to tackle. And I think reused steel has proven, especially I've seen a couple of jobs with CLT, you can get a very low number for the embodied carbon value for a building by going this route. And that's without the mix and match solution does work. If you look at mixing and matching reuse with electric arc furnace steel with some new, you can bring the number down to a much more acceptable number. And that's the advantage with this 47 kilos. If you've got 20% of your steel at 47 kilos, 80% of it, I can't do the maths in my head, but 80% of it at 1.8 tons, suddenly your average on the whole site has come down markedly. It's not that you're not making any difference, you're making a big difference.
Mm-hmm. Cool. And then Tom, just picking up on the point with maybe dictates from local councils as opposed to central government, how does that sort of relate to what your two companies do then, in terms of do you have a minimum order size as such? I mean, what's your average? I mean, do you worry about providing 6, 8, 10 tons, or are you always sort of striving to look at bigger projects?
Yeah, this is something where we actually differ slightly between our two companies. That we've been looking at larger projects, supplying a small percentage to a larger project. So we might, take 100 tons on a 1,000-ton project, or 500 tons on, a much bigger project. But we don't necessarily have a minimum order size. What we're finding is that with the demand, because everyone wants to get this really great carbon benefit from their new building, the demand is massively outstripping the supply. So we actually don't have any problem supplying. I mean, obviously we've got the challenges that we've got to get it to the point where we can get it on the supply. But in terms of the demand to get it, it's there. We don't have a problem selling it. It's more the problem of getting it out of buildings and taking it through a process, and so we can have enough. But yeah, in terms of, so we can actually be quite selective on the projects that we supply to, and actually understand that, say, if someone wants to take our material and use it in a way that we think might be inefficient, we would actually say, if you're trying to take a beam that's twice as strong as it used to be because you want to get that carbon benefit, but we've got another project that would have a much higher carbon benefit for using it, we can actually be quite selective on that and actually communicate that. And I think people are receptive to that messaging as well, saying that actually we're going to be honest, and if we don't think your project is right for reuse steel, we will tell you that. I don't know what you're taking it as, Roy.
Yeah, I mean, we're a bit broader brush, so I quite like some of the smaller projects, but we've also got a good transport network we can use internally within our group. So I've delivered stuff that's 3 tons, 2 tons to domestic refurbishment because we can do that. I do prefer to have a broader spectrum of clients as possible, because some of the smaller clients can be more accepting of some of the anomalies than the larger ones. We've got our own fabrication facility. We're CE accredited. We're not a big fabrication facility, but if it was a small domestic refurbishment, even up to 20 or 30 tons, we can potentially do that work in-house, which gives us a much greater control over what material can be accepted or not. And by that, I mean existing attachments or drill holes or things that come with reused steel. So we would engage the same as Tom in the bigger projects, but our minimum order quantity is £500. That's not delivered. That's the one thing people tend to forget about, is how expensive it is to get stuff up and down the country. But it's, talk to us about anything. It makes very little difference to us on the size of the job. We just look at whether, again, back to Tom's message, whether the material's suitable or not.
Yeah, cool. I mean, this session came out from a conversation that Tom was involved with Charlie Luxton, where he was like originally to the point about how it's relatively easy for very small projects or architects looking to create bespoke properties using reclaimed materials, but like Charlie was trying to challenge the community. So we wanted to know answers on how big can this stuff get, how can it be broadened out so every sort of sector is using reclaimed materials. So it's interesting to see where we are. Like when you're going back to your chart here, that 1 million tons recycled and 1,000 is reused, and sort of with the vision to get into a point where those numbers of reuse is a lot higher, albeit that's, you know, I take the point that that's lower figure is not meant to scare people. So we just have a couple more minutes. Is there anything that you would like to raise? Just, I mean, is there a question that you often get asked that I haven't asked, or that should be raised, and we can sort of, if so, yeah, have a free form platform there just to do your bit.
I just think it's important. I mean, this is what I'd say is kind of closing off, is that understand that these kind of reuse initiatives, especially with steel, it is possible. And a lot of people are kind of, when you raise it to them now, and saying, "Oh, what about this? What about this?" But actually, if you were to come to someone like us or Cleveland, we would actually say we've kind of solved a lot of these issues. So just understanding, being really open-minded on everyone here who's got different portfolios of projects, that being really open-minded that if you think it's possible, you know, there's an opportunity there, then there's a good chance it will be possible. So kind of raising that awareness and looking for those opportunities, especially for the recovery side. If you've got material coming out of the buildings, then you should be looking at what can you recover, because that's what's enabling this big carbon saving is actually enabled material coming out. So yeah, just being open-minded, looking at all your projects and saying what is possible, what are the opportunities. And you don't have to have the answers to every single problem that might come up, because when you come to people like me and Roy, we probably can help you out with that and give you some of the answers.
Cool.
Yeah, I think the most important thing to remember is that steel doesn't deteriorate. So people worry about it being second-hand, but its performance is actually the same as new, with various provisos, but they're not really an issue, to be honest. So there are cosmetic aspects of it being reused. There are other functional aspects, the nitty-gritty I was talking about. But the performance of the material doesn't really need to be doubted, which is one of the biggest benefits. And as long as you sort of remember that, then it sets the tone throughout. I think the other thing ultimately, which is going to change the landscape completely, is if, such as the RICS proposal on carbon calculation starts to take account of the building you demolish before you build the next one. Because if carbon targets for demolition get introduced, so you're not allowed to flatten a building as if it didn't exist in terms of carbon before you build the new one, then that's going to oblige people to recover more materials to assess the carbon impact of that. And it's not just a question, because I'm not saying we should never build anything again. Everything should be refurbished. That doesn't work. But if in fact the true cost of a new building takes account of the cost of getting rid of the old one, and I'm talking carbon costs now, that will be probably, to me, that would be the single biggest change in the landscape, because we know the demand exists. So it's getting the supply side. And it's also not designing things so that they're rubbish later. This probably doesn't come down to architects, but engineers. I've seen it where buildings, steel structures have got endless service holes in case they're necessary. So you've perforated the steel umpteen times over, which makes it much degraded for future reuse, because we've tried to do too much speculation at the outset. I think things should be built with a view to what value they're going to have when they come down.
Yeah, definitely. And to your point about the assessing carbon impact, I mean, we're as Mesh Energy, we're seeing that. So, you know, there's planning authorities in South Ham, South Devon, among others, that are now stipulating that you need to undertake a carbon assessment. If you want to knock down and build a new house, then you have to tell us the impact of doing so. And yeah, that's
really, yeah, it's really important to actually look at the impact. Some people get a bit kind of, sometimes these guidances get a bit misled about, they look at what the original carbon of that building was, and that's not always the best way of looking at it, because that carbon's been emitted. We can't change that. You know, that's a past emission. What you kind of really want to look at is what are the carbon impacts, the decisions that I'm making today. So that decision is actually between, say, retention, reuse, and recycling. So you can look at what you're retaining, what you're recycling, what you're reusing, and that's your decision. That's your carbon impacts, and they all have different carbon impacts. So it's not just kind of doing a carbon assessment on your existing building. It's looking at the decision making, which is we find really important.
Cool. Right. I think we come up to our time now. So no, thanks Roy. Thanks, Tom. Really, really interesting, really helpful. I've learned a lot, most definitely. Like I said, this session's being recorded. We'll upload it and I'll share the links with you guys. But no, thanks for your time. Really, really do appreciate it. I know you've got busy days. So thanks for everyone else for attending. And yeah, we'll see you on the next webinar. Cheers, guys.
Yes.
Yes, I do, Tom.
Yes. Shall I set it up as a... Yeah.
So I'm going to shut this down now, Tom. If you want to, pick up with.
I'm just going to give Roy a quick cough. Yeah. So
cool. All right. Okay. Cheers, guys. Thanks.
Thank
Bye.
you.
Bye.